Hi, okay, now we're going to start with number 39 and see how far we can get in a short video. Find the local minimums and maximums for this function. Actually, since they give you the graph, we're just going to go with the graph. We're going to estimate. Now, local minimums and maximums are turning points. So these are two local minimums. And up here, this little bump that's kind of hard to see, that's a local max. Okay, so we have to estimate where they are at. Now for this up here, I'm just going to say it's at 0, 1, 2, 3, 4. 0, 4. On the test, the graphs will be better than this. For the local minimums, back here at -1, and then the x or y value would be 1, 2, probably about 2.2. I'm just estimating. And then this other local minimum. Looks like a match up here. 1, 2. X is 2, and y looks like it might be 1, 2, 3. Wait, 1, 2, 3, 4. About -4.5. Okay, as long as you're close, that should be fine. All right, number 40. We're getting into simplifying radicals. 32, if you do the prime factors of 32, you'll find it's 2 times 2 times 2 times 2 times 2. Since we're taking a square root, you need a pair. 2 times 2 is 4, square root of 4 is 2. So each pair of 2's I can take out as a square root and put a 2 out front. This 2 doesn't have a buddy, so it's going to stay underneath. Outside, 2 times 2 is 4. Underneath, square root of 2 is left in there. So 4 square root of 2 is for number 40. 41. We don't like having radicals in the denominator, so we're going to get rid of that square root of x by multiplying the numerator and denominator by square root of x. So 3 square root of, square root of 6. 3 square root of 6 over square root of 6 times square root of 6 is 6. We're not done because we can reduce this. 3 and 6 are both divisible by 3. 3 by 3 is 1. 6 by 3 is 2. So the final answer for number 41 is square root of 6 over 2. All right, number 42. Look at this. It's got a complex number in the denominator. In order to get rid of the 2 plus I in the denominator, we have to multiply by the conjugate. The conjugate has the same terms, 2 and I. It's just instead of addition, we change it to subtraction. Same terms, opposite sign. In the numerator, we're going to have to distribute the 5 to the 2 minus I. So we end up with 5 times 2 is 10 minus 5i. The denominator, we have two basic binomials here. We're going to have to multiply them together. So we end up 4 minus 2i, and then plus 2i. And then I times negative I is negative I squared. Now, two things you're going to have to remember, and have this on your note sheet, is that I is equal to square root of negative 1. So I squared is equal to negative 1. So in this problem, I can replace this I squared with a negative 1. Now that was a negative I squared, so negative 1 makes it the same as positive 1. So to simplify this, the numerator will stay the same, 10 minus 5i. And the denominator, 4 plus 1 is 5. The negative 2i and the 2i, they're like terms, and they'll cancel each other out. All right, we're almost done. 10 minus 5i divided by 5. Both those terms are divisible by 5, so we'll do that. 10 divided by 5 is 2. 5 divided by 5 is 1. So we end up with 2 minus 1i, or just 2 minus I. All right, so that looks kind of nice. All right, moving on to number 43. Exponent rules, they never go away. ABC to the third divided by a to the fifth, b to the fourth. Okay, a to the first in the numerator divided by a to the fifth. I'll take 1a out of each. I'll end up with a to the fourth in the denominator. Then I have b over b to the fourth. I'll take one of the b's out, and in the denominator I'll have a b to the third left. Now, I just have a c to the third left for the numerator. I can't cancel with anything. Okay, so that's the answer to 43. C to the third over A to the fourth, B to the third. Number 44. I like this problem. Look at that. It's got 4 terms, so you check. It's set up perfectly for factoring by grouping. Now, just because it has 4 terms doesn't mean it'll work, but it's worth a shot each time. 2x squared plus 8x. I can take 2x out of each of these. 2x squared divided by 2x is x. 8x divided by 2x is 4. Okay, then bring down the plus. 3x plus 12, they're both divisible by 3. Take 3 out of the 3x, you have x. 12 divided by 3 is 4. Okay, so factoring by grouping is going to work because our 2 binomials that we factored out are the same. They match, so the first binomial is going to be x plus 4. The second binomial, it's what I like to refer to as leftovers, is going to be 2x plus 3. All right, the next problems. Yeah, let's get those two done. 45 and 46, subtracting and then multiplying complex numbers. 45. Okay. 3 plus I minus the quantity 7 minus 8i. I like changing subtraction, adding the opposite. So plus negative 7 plus 8i. So 3 plus negative 7 is negative 4. And then I plus 8i. Oops. I plus 8i is 9i. So we end up with negative 4 plus 9i. All right, 46. We did one like this earlier. It looks like 2 binomials. We're going to multiply together. And then when we're done, we'll have to simplify the i's. So 4 times 3 is 12. 4 times negative 5i is negative 20i. 2i times 3 is 6i. 2i times negative 5i is negative 10i squared. Okay, so our I squared is the same as negative 1. So I'll end up with negative 10 times negative 1. Well, negative 10 times negative 1 ends up being positive 10. So 12 plus 10 is 22. Combining the two middle terms, negative 20i plus 6i is negative 14i. All right, we'll stop there. I'll get some more problems on another video. Okay, make sure you make a nice note sheet. Definitely include I equals square negative 1 and I squared equals negative 1. Okay, have a good weekend.